That rumble in your chest, it's not just music, it's physics bending air to its will. Every time a speaker makes a sound, whether it's the booming bass of a concert or the gentle whisper of a podcast, it's performing a tiny, intricate dance. A dance between electricity and magnetism, a silent ballet that transforms invisible energy into the audible world around us. But how does it do that? How does a piece of plastic or paper, connected to some wires, magically push air in just the right way to create the rich tapestry of sound we experience? It's a question that delves into the heart of electromagnetism, a force that silently orchestrates so much of our modern world. At the core of every speaker lies a fundamental principle discovered centuries ago: the interplay between electricity and magnetism. Picture this: a wire carrying an electrical current. Around that wire, an invisible magnetic field forms. It's a subtle but powerful phenomenon. And if you place that current-carrying wire near another permanent magnet, something remarkable happens. The two magnetic fields interact, either pushing each other away or pulling each other closer. This push and pull is the secret sauce, the fundamental force at play. Now imagine a tiny coil of wire, often called a voice coil, nestled within a powerful permanent magnet. This is the heart of our speaker. When an electrical signal representing the music or voice flows through that voice coil, it momentarily becomes an electromagnet. The electrical signal isn't a constant, steady flow. Oh no, it's a rapidly fluctuating current mirroring the complex waveforms of the sound it's trying to reproduce. It's a tiny electrical dance, moving with incredible precision. As this fluctuating current passes through the voice coil, the coil's magnetic field changes in strength and polarity, dozens, hundreds, even thousands of times per second. It's like a tiny, invisible hand rapidly flicking a switch. This ever-changing magnetic field of the voice coil interacts with the steady magnetic field of the permanent magnet. One moment, they push away. The next, they pull together. This constant push and pull makes the voice coil vibrate. Connected to this vibrating voice coil is the speaker's diaphragm, often a cone-shaped piece of paper, plastic, or even metal. As the voice coil moves back and forth, it drags the diaphragm with it, making it vibrate too. And this asterisk is where the magic truly becomes audible. When the speaker cone vibrates, it pushes and pulls on the air molecules directly in front of it. Imagine it like a tiny, incredibly fast piston pumping air in and out. When the cone pushes out, it compresses the air molecules, creating a region of higher pressure. When it pulls back, it creates a region of lower pressure. These compressions and rarefactions, as they're called, travel outwards from the speaker like ripples on a pond. These traveling pressure waves are what we perceive as sound. They hit our eardrums, causing them to vibrate, and our brains interpret these vibrations as the symphony, the podcast, or the voice we're listening to. It's a truly elegant chain reaction. Electrical signal to magnetic force to physical motion to air pressure changes, and finally, air pressure changes to perceived sound. All orchestrated in fractions of a second. The frequency of these vibrations determines the pitch of the sound. Faster vibrations mean higher pitches, like a flute. Slower vibrations mean lower pitches, like a tuba. The amplitude, or how far the cone moves, determines the volume. This basic principle applies to almost all dynamic loudspeakers, from the tiny earbuds in your pocket to the massive subwoofers at a concert. The size and materials might change, but the core physics remain the same. Think about the sheer engineering involved. To reproduce a complex piece of music, a speaker must accurately vibrate its cone thousands of times a second, with varying degrees of force, all while staying perfectly in sync with the original audio signal. And the materials matter. The stiffness of the cone, the strength of the magnet, the winding of the voice coil, each element is carefully chosen and optimized to produce the clearest, most accurate sound possible. It's a delicate balance. So the next time you hear your favorite song, or even just the voice of a loved one on the phone, take a moment to appreciate the hidden physics at work. That sound isn't just appearing out of nowhere. It's the carefully controlled dance of an electromagnet, pushing and pulling air, translating an invisible electrical current into the rich, vibrant soundscape of our lives. It's a testament to the elegant simplicity of physical laws. From the quietest whisper to the loudest roar, every audible experience from a speaker is a direct result of these fundamental interactions. It's physics, made audible, constantly unfolding around us. And it's just one more example of how the ordinary objects in our daily lives are actually brimming with fascinating scientific principles.